Hello students. In our previous video, we learnt construction of similar triangles of a given scale factor. Let us learn today how to construct tangent to a given circle from a given point. This given point can be anywhere. It may lie on the circle or outside the circle. But students, take a second, pause the video and think, can this given point lie inside the circle? We already know that if a point lies inside the circle, there cannot be a tangent to the circle through this point because line passing through this point will cut circle at two distant points. But by definition, a tangent is a line that touches a circle in unique, that is, one and only one point. So, we will never get a case where point is inside and we have to construct tangent from it. Now, if the point lies on the circle, we know that in such a case, there is only one tangent to the circle at this point, and it is perpendicular to the radius through this point. And if the point lies outside the circle, then there will be two tangents from this point to the circle. Also recall that the radius of the circle and tangents are always perpendicular to each other at the point of contact. So, the tangent to a circle is also defined as the line perpendicular to the radius at the point of contact. First, let us see how to construct a tangent to a circle from the point on the circle. We know that radius and tangent of a circle are perpendicular to each other. So, if you want to draw one tangent at a point on the circle, simply draw the radius at this point and draw a line perpendicular to this radius, and this will be the required tangent at that point. Say we are given a circle with center P with radius 6 cm and a point A lying on it. Let's see how to draw a tangent at this point. Step 1. Draw a circle with 6 cm radius with center P. Step 2. Join center of the circle P and point A on the circle. We know that PA is the radius of the circle. Step 3. Draw a line perpendicular to radius PA at point A. For drawing perpendicular, we will draw a line which makes angle 90 degree with radius. And I am sure you know how to draw 90 degree angle. In case if you don't remember, don't worry, it is easy. Using the compass with suitable radius and with A as a center, draw an arc that cuts the radius AP at a point C. With the same radius and C as the center, draw other arc that cuts the previous arc at D. We know this makes our 60 degree angle. Now take D as a center and with the same radius, draw another arc and name it as E. This will be 120 degree angle. Now with the same radius and with D and E as center, draw two arcs one by one such that they cut each other at F. This is being angle bisector, it will be 90 degree angle. Now join the points A, F. We can observe that angle FAP is equal to 90 degree. Thus we can say that line AF will be tangent to the given circle at a point A, which is on the circle itself. Now what if this point A is outside the circle? We know that there can be two tangents passing through this point. So let's learn how to draw two tangents to a given circle from a point lying outside this circle. Suppose we have a circle of radius 6 cm and from a point 10 cm away from its center, we want to construct the pair of tangents to this circle. The steps of construction are: Step 1. Draw a circle with center O and radius 6 cm. Mark a point at 10 cm from center O with ruler. Step 2. Join point A from outside the circle with its center O. Step 3. Construct perpendicular bisector of the line segment AO. For this, take compass with radius equal to more than half of length of AO. Taking A as the center, draw an arc below and above the AO. Now taking O as the center with the same radius, draw two other arcs, one above and below each, so they intersect previous arc at M and N. Now join MN. This is the required perpendicular bisector of AO, intersecting AO at point P. Thus, P is the midpoint of line segment AO. Step 4. Draw another circle taking P as center and PO as the radius. This circle will intersect on the previous circle at 2 points B and C. Step 5. Now join these points B and C with the point A, making the two line segments AB and AC. These are the required tangents from the exterior point A. Thus, AB and AC are the required tangents through points B and C on the circle from exterior point A. Now, let us give reason why AB and AC that we constructed are tangents to the circle with center O. It is observed that AO is a diameter from the circle with the center P. This is because we have drawn circle of center P taking PO as a radius. Therefore, AO being diameter divides the circle into two semicircles. Observe that on joining O and B, OB forms the radius for the circle with center O. Therefore, angle ABO is an angle in upper semicircle, and therefore angle ABO is equal to 90 degree, because angle inside the semicircle is always right angle, and by definition tangents are perpendicular to the radius. Since by our construction AB is perpendicular to OB, where OB is the radius of the circle, AB is tangent to this circle with center O and radius OB. Similarly, if we take the lower semicircle, we can prove that AC is also the tangent through the point C to this circle. So now we can say that our construction is right. That is, AB and AC that we have drawn are tangents to the circle. Students, observe that here we were already given a circle with its center, and we were also given the distance of the point from which we had to construct the tangents. But what if this distance is not given? And in place of distance, we are given angles between these two tangents. Can we still construct tangents in this situation? We will see it in our next video.